You drift deeper now into a single unfolding moment, entering the mysteries of superposition, a place where particles can exist in multiple states at the same time, until the universe softly decides. You start to sense the quiet vibration of entanglement, where two particles separated by immense distances stay mysteriously linked, so that what happens to one instantly affects the other, as if the universe connects them with invisible threads. Here, cause and effect blur together. The universe doesn't just allow uncertainty, it is made from it. Yet within this randomness lies a special kind of order, a harmony that moves not in straight lines but through probabilities, in patterns that only appear when viewed through the right lens. Quantum mechanics does not destroy predictability, it transforms it. It shows us that while we can't know exactly where something is or exactly how fast it's moving, we can know the shape of its possibilities, the graceful curve of what might be. As you breathe deeply, letting this understanding sink in, you feel how the world still holds its shape. The table, the ground, the stars all seem solid and stable, not because quantum rules disappear, but because when countless probabilities come together, the blur sharpens. The uncertain turns into the predictable, the randomness of the very small averages into the order of the very large. But here, in this quiet moment, you are floating not in the familiar certainty of the large-scale world, but in the delicate unfolding of the quantum realm, a place where existence hums softly with uncertainty. Here, reality does not exist in a fixed way until it is observed, or perhaps more accurately, reality is always a symphony of possibilities that only sometimes collapses into the notes we can see, hear, and touch. As this gentle wonder fills your mind, you drift toward the next whisper of curiosity, the realization that even the act of knowing has its limits. The universe quietly reminds us there are boundaries to how deeply we can look into its secrets. The more you try to grasp one truth, the more another slips away. Waiting patiently in the shadows of uncertainty, you float now into the quiet mind of Werner Heisenberg, a young physicist sitting by a window as soft morning light falls across pages of equations. His thoughts are wrapped around something subtle and unsettling, something that refuses to be fully captured. As you breathe beside him, you feel the tension between knowing and not knowing, the realization that uncertainty isn't just a flaw in our tools, but a fundamental part of existence itself. Until then, it was possible to imagine the universe as fully measurable, as though with enough care, we could record every particle's position and momentum perfectly. But the quantum world whispers otherwise. As Heisenberg watches electrons flicker in and out of clear locations, he realizes the more precisely you know where something is, the less you can know how fast it moves. And the more clearly you know its speed, the more its position fades. This is not a failure of measurement. It is a feature of the universe, a gentle veil covering the tiniest pieces of reality. Imagine holding a softly glowing marble. As you try to focus on its exact position, its edges begin to blur, spreading into a gentle cloud. The sharper you focus on one aspect, the softer the other becomes. This is the uncertainty principle, a quiet law of nature telling us that the universe does not like being examined too closely. It prefers to show itself in whispers, in patterns of probability rather than precise certainties. As you drift further into this idea, you see its beauty. It feels comforting to know that nature protects her secrets not out of stubbornness, but perhaps as a gentle reminder. The world is not something to conquer through knowledge alone, but something to experience with curiosity and wonder. Heisenberg's insight does not arrive in a sudden flash, but through a slow realization that the act of observing shapes what can be known. In the quantum world, the observer and the observed are always linked in a delicate dance. It is this dance, this impossibility of perfect precision, that gives the microscopic world its unique softness. Electrons do not orbit like tiny planets. Instead, they shimmer in clouds of possibility, existing here and there until observation nudges them into place. You now feel the quiet tension of this truth, how it ripples from the smallest scales into the larger world. Though, in our daily lives this uncertainty is smoothed out by countless atoms and enormous numbers. It is always there, softly humming beneath the surface, a gentle blur at the edge of certainty, Heisenberg's principle becomes more than a rule about measurement. It becomes a window into a deeper truth, that reality is a mosaic of probabilities, woven together by our act of observing, by our very awareness. As you drift gently through this realization, you sense that this soft veil of uncertainty is not the end of the mystery, but the beginning, a doorway to even deeper questions about observation, reality, and existence itself. And so you find yourself softly floating toward the next unfolding, where quantum's strange rules appear not just as curiosities of the small, but as the foundation holding everything together, quietly waiting for the next chapter to be revealed. You drift gently now back to where this journey began, to the soft glow of heated objects, and to nature's quiet refusal to fit neatly inside the boxes of classical physics. The puzzle that lingered for more than a century, like a soft whisper waiting for someone to listen more deeply, now starts to come together. As you drift through this unfolding moment, the pieces finally find their place. They are no longer forced to match a picture that was always incomplete. The ultraviolet catastrophe, the paradox that once made equations blow up into impossible infinities, now fades quietly, like mist under the morning sun. With the arrival of quantum thinking, with the surprising realization that energy comes in discrete packets, the particles blur between waves and points, that certainty itself is a gentler concept, the problem starts to dissolve. Old equations once demanded that energy spread endlessly into higher and higher frequencies, leading to absurd predictions. But with quanta applied, with Einstein's photons accepted, with Heisenberg's uncertainty embraced, the math finally aligns beautifully with what nature reveals. When an object glows, radiating warmth and light, it doesn't do so as a smooth, continuous wave, but as a delicate cascade of quantum steps, each frequency holding its own small packet, its own grain of energy. With this graininess, the runaway infinities vanish, replaced by curves that match exactly what we observe. You float now in this realization, sensing how the rise of quantum physics isn't merely about fixing a flaw, but about revealing a completely new way of seeing reality. The smooth, predictable clockwork universe of Newton yields softly, not through destruction but with quiet grace, giving way to a universe that is richer, softer, stranger, and yet more true. The tiniest pieces of existence are no longer thought of as small marbles or perfect gears, but as clouds of probability, as patterns of chance shaped simply by being. The glow of heated objects, once a stubborn puzzle, becomes a doorway, an invitation into this new world. As scientists in the early 20th century accept this language of quanta, they see that it extends far beyond black-body radiation or the photoelectric effect. It reaches into the structure of atoms, the bonds of molecules, and the ways matter holds itself together. The very fact that you are here, breathing, thinking, resting, echoes these quantum rules. Every moment, every feeling, every thought is built from particles that shimmer in uncertainty, yet together create the stable comfort of the world you know. You drift now in the realization that the puzzle was never a flaw, but an invitation from the universe to look deeper, to peel back the smooth surface and see the gentle, glowing weave beneath, a fabric stitched from probabilities and possibilities, from patterns that reveal themselves only when asked. Even here, in resolving this old problem, the mystery doesn't end. As classical physics bends into this new form, it becomes clear that quantum mechanics solves one challenge but introduces countless more. Questions ripple forward into the puzzles of entanglement, into the paradoxes of superposition, into the strange idea that particles can affect each other instantly across vast distances, as though the universe holds hidden threads. As you breathe slowly, letting this understanding settle, you feel a gentle pull toward the next chapter, a place where each answer opens into even deeper questions about the nature of reality itself. You float now in the quiet space that follows understanding, that gentle moment where answers dissolve not into final certainty, but into broader, deeper questions. Like a ripple that never quite reaches the shore, you sense the quiet truth that the universe isn't a puzzle to be completed, but a song that never ends. Each answer hums softly leading to another verse, another note, a rhythm of mysteries unfolding without end. The 125-year-old problem that brought you here, the stubborn glow of heated objects, has dissolved like fog in sunlight. Not erased, but transformed. In its place stands not a simple solution, but an invitation, an open doorway into a reality more beautiful and strange than classical physics ever imagined. Imagine discovering that energy comes in tiny packets, that particles are not little marbles, but clouds of probabilities, that uncertainty isn't a flaw in measurement, but a feature of existence itself. All of this reshapes how you breathe, how you rest, how you exist. Every atom in your body follows these rules. Every flicker of thought, every gentle rise and fall of your breath is an echo of quantum rhythms, and yet, even here, the universe keeps some secrets. For every breakthrough like Planck's quanta, Einstein's photons, or Heisenberg's uncertainty, 1,000 new questions bloom. How does entanglement truly work? How can particles influence each other instantly across distances? As if the fabric of space holds hidden threads? How does the wave function collapse? Does it collapse at all? Or do all possible outcomes continue somewhere in the quiet branching of reality? And if the entire universe follows quantum rules, what does that mean for the cosmos as a whole? Could there be worlds where every possibility plays out quietly alongside ours, shadow universes softly brushing against our own, unseen, unknowable, yet possible? As you move through these thoughts, you start to feel that the edges of knowing aren't walls but horizons, places where curiosity stretches out forever, never reaching an end, only opening wider. Like a sky that grows larger the longer you look, the birth of quantum physics didn't mark the end of confusion, but the beginning of a new kind of wonder, the realization that certainty was never the true goal, but rather the gentle practice of listening, of asking, of watching how nature responds. Here, floating on this current of thought, you begin to understand that the universe is not a finished thing. It isn't a story with an ending, but a living, breathing unfolding, a soft whisper stretching from the tiniest flicker of a photon to the widest spread of galaxies, from the grains of energy in heated matter to the dark fabric holding the cosmos together. As your breath slows, as your body settles into rest, you carry with you the quiet comfort of knowing that the search for understanding is a beautiful part of being alive, a gentle dance between what is known, what is not, and what may never be fully understood. And perhaps that is how it is meant to be, a universe forever unfinished, forever singing softly just beyond what you can see, forever waiting patiently for the next curious mind to listen.